Okay guys, in 11.4 we're going to focus on graphing and domain. So if yours says inverse, we're going to scratch that out because we just did that in 11.3. Now, we have some restrictions. So this is your basic log graph, right? And if you remember, there is a vertical asymptote at 0. So once we start adding, subtracting, and multiplying onto this, our asymptote switches and the way our graph looks switches. Okay, so first of all, we could be doing this by transformations, but let's start doing domain by algebra, and then we can look at the graphing calculator on how to sketch it. Okay, so here's an example down below. As you can see from our original graph, our domain is restricted from 0 to infinity, right? Because of the asymptote. Now, that means that anything in the log cannot be negative or 0. So what we're going to do is set what's inside the log greater than 0, not equal to, so be careful. Okay, and then we're going to solve. So x, it has to be greater than -1. If we were to put this in interval notation, then we know it's -1 to infinity. What that does to our graph is it moves, remember, adding 1 on the inside moves it to the left one. So everything moves to the left one. Now I'm going to show you how that looks in our graphing calculator. So I have, here we go, y equals, and we have log base 4. Well, to sketch this, we're going to have to change our base. If you go to math, and you go all the way down, you will see that it gives you a log of a different base. So we can fill this in. So base 4, and we're going to go x plus 1. And now when we graph it, and as you can see, my window's set differently, so I'm going to have to change the window. I'm going to change it -10 to 10, -10 to 10. Okay, what happens on our normal graph here is we know it's going to come down here. So that's why we can sketch from the graphing calculator. But there is an asymptote at -1. You see how it starts to go down at -1? So when we graph on the graphing calculator, guys, I want you to see where it's about to go down, and that will be your asymptote. Alright, so let's do a couple of these together. Well, let's do our domain first. What is it that we have a restriction on? Well, what's inside the log is what we're restricted on. So we have 4x plus 1, and that has to be greater than 0. And then we're going to solve. So we get rid of the 1 first by subtracting it, and then we get rid of the 4 by dividing it. So in interval notation, this goes from a -1/4 to infinity. So if we were to graph this or make a sketch of it, first of all, I know that 1/4 is going to be in there somehow. So let's check. Y equals, now I'm going to just change the base since I already have that. So let's go insert -2. And then change that to 5. We have 4x plus 1, and then plus 3 graph. Alright, well this makes sense too, because if you remember correctly, a negative out front is going to flip it, so that's really nice. I bet you that that asymptote right there is at -1/4. And truthfully, that is where we find it. I mean, look back at the example, guys. Look, our domain went from -1 to infinity. And where was our asymptote? -1. Same thing with our original graph. It goes from 0 to infinity, and our asymptote's at 0. So when we solve this algebraically, we definitely can say that where we end, so -1/4, is our asymptote. Okay. Now what we might want to do is find out if there is another point in here that we can label to get our sketch more accurate. So I'm going to go second and graph, and that gives me my table. So as you can see, I have a couple points I can write here. 0, 2, 3, 1, 1, 6, 1, 3, 4, 5, 6, -1, and I say we got a good graph coming here. So this is going to come up really close to -1/4, and this is going to keep going down. And there we go. There's our nice little sketch right there. Let's do that one more time. Make sure we have everything put together. So we have, what is our restriction is 5 minus 3x has to be greater than 0. So let's solve. We get -3x is greater than, so we're subtracting 5 from both sides. And then we divide by -3. Uh-oh, we're dividing by negative. What does that mean? That means we flip the sign. Remember, that was an old property, an old fact that we learned with inequalities. When you divide or multiply by a negative number, you flip the sign. So we would have -5 over -3, which would be 5/3. Now, because we flip the sign, guys, that also means that we are now less than. Well, less than is negative infinity, and then we're going to 5/3. Alright, sketching our graphs. That still means that this is our asymptote. So 5/3, that's a little bit over 1. Okay, so I'll label that as 5/3 so you guys can see that. So I'll do my dotted line. Now the other thing is this, because it's negative infinity, it means the graph is going to be on this side, okay? So let's grab our graphing calculator, go to y equals, let's clear that out. Now there's no base, so who remembers what that base actually is? It is 10. But we know that our calculator just gives us a log on here, so log, and then I can fill that out. 5 minus 3x parenthesis plus 1. Let's graph. And look, it's on the other side, which is what we predicted. But let's get some points in there to make sure we have them correct. So second graph. Alright, so I'm going to have to move this, and I want some nice points. It would be nice if they got some nice points, but it looks like it's not happening. So, alright, so I'm going to do some estimating here. So 1.3, so 1.3, so somewhere above here. 0, 1.67, so it looks like it's coming here. So again, this is a sketch, guys, so don't worry about it being perfect. But there we go. Mostly when you guys graph it, I want to make sure that you have that asymptote correct and that it's curving in the right direction, okay? So recap. Your basic log is going to have your asymptote at 0, and your log is going to be increasing, okay? But if we shift it by having a negative out front, that means we're reflecting across the x-axis, so we're actually decreasing. And here, when we have a negative on the inside, we are reflecting across the y.